So let's look at these algebraically now. All right, if my function was f of x equals 2x minus 3, how would I find the inverse of that? How would I find the inverse function?
I don't know.
This is the way I like to do it. There's other ways to do it, but this is the way I like to do it. I like to rewrite this as y equals 2x minus 3, and then I switch the x and the y. And then I solve for y again. I'm trying to see if the y can be written as a function of x. So what I do first is I would add 3 to both sides. And then I get x plus 3 equals 2y. And then how would I get the y alone? Divide by 2. I would divide by 2, divide by 2. And so then my y would equal x plus 3 divided by 2. Now that's not exactly what I see right here. That's just because they wrote it just slightly differently. Instead of writing x plus 3 divided by 2, they took the 2 out and they said 1/2 times x plus 3, which would give me the same thing as that. Right? You guys see that? They would. Okay, so this is how you find the inverse function. Now, how do you test to see if it's an inverse function? If you want to test it to see if it's inverse function, what you're going to do is you're going to take the inverse function and you're going to plug it into the other function. So it looks kind of like this. It's like the composition. Remember the fog problem, some of you guys call it? F with F inverse inside of it. When you do this, you should get x. If they're inverses of each other, everything starts canceling out, and we're left with an x.
Just one?
Yep, just one x. So look, this is what it looks like. Let's take this function right here. We have 2 times something minus 3. What's that something? It is x plus 3 over 2, or you can write 1/2 times x plus 3. What is 2 times this? 2's cancel out, right? And then I get x plus 3 minus 3, and what happens to those 3's?
It equals x.
Boom! That means they're inverse functions.